Hi there. In this video, we're going to look at a component of congruent standard 9, which asks us to prove theorems about lines and angles. And in particular, we're asked to know how to prove that when a transversal crosses two parallel lines, the alternate interior angles are congruent. Okay, and before we get started on that, let's just step back and remember that in general, alternate interior angles aren't congruent. In fact, normally they're not. But we can make that happen under special circumstances. In particular, when the lines are parallel, then those angles do become congruent. Some of the intuition behind seeing that they're congruent comes from performing a 180-degree rotation around this point right here. And that gives us the sense that they really ought to be congruent. Okay, so with that, let's go down to the proof. Before we get started, just the idea of the proof, we want to show that x equals to y. So what we're going to do is show that this blue angle matches the yellow angle, and then we'll show the yellow angle matches the green angle, and from that we'll know that the blue and green angles have to match each other, showing that the alternate interior angles are congruent. So that's kind of the idea of the proof in one screen. And let's go ahead and get started on this. So in this theorem, we're given that line J is parallel to line K. And we would like to show that a pair of alternate interior angles are equal. So we'll show that x is equal to y. All right, first statement, we're given that line J is parallel to line K. We can't do the proof without that information. Very important. Step 2, let's look at x and w. Okay, and you can see that if you were to perform a translation, x would map to w, which we call corresponding angles. And we know that when two lines are parallel, the corresponding angles are congruent, so that tells us that x is equal to w. And here's a quick visual to go along with that. We see that the yellow angle maps via a translation to the blue angle. Okay, so x is equal to w. Next step, looking at w and y, we see that they are vertical angles, and we know that vertical angles are congruent, so w must be equal to y. And at that point, we've now shown in our work that x matches w and w matches y. And therefore, we should be able to conclude that x and y match because they both match w. So that's what we'll do. Step 4, x and y are both equal to w, so that means they have to equal each other. Once again, blue and green both match yellow. That's what's up. Okay, so we've now proved that x matches y, and x and y are alternate interior angles. So we've now proved that when two lines are parallel, the alternate interior angles must be congruent. And that's our proof. Okay, one last thing with this. Just to do everything in one screen, all right, so that you see in the space of about 30 seconds how this argument goes, and then it really isn't too complicated if you stop and think about it. All right, so step 1, we're given that line J is parallel to line K. We know that with parallel lines, your corresponding angles are congruent, so x has to match w. We know vertical angles are congruent, so w has to match y. And both of these match w, so they match each other. And that proves the theorem. That's it. I hope this video was helpful in helping you to master Standard 9, and we'll see you next time.